Good morning everyone, and in this class we are going to discuss one more concept related to the heredity. Important concept, that is monohybrid cross. Monohybrid cross. Then what it means, monohybrid cross? Okay, monohybrid cross, the word itself represents that is mono, single, hybrid, cross. Okay, here the cross between two individuals. Differ in single contrasting character. Single contrasting character. Okay. You know that contrasting means opposite character. There is single contrasting character. Those two individuals which undergo cross, they differ in single contrasting character. Okay, here this monohybrid cross and dihybrid cross, these experiments are conducted on garden pea plants. Garden pea plants by Gregor John Mendel. And he is known as the father of heredity, as well as the father of genetics. Okay, he conducted many experiments on the garden pea plants. Okay, here these pea plants shows number of easily observable contrasting characters. Okay, for example, related to the height of the plant body, it shows two contrasting forms, that is tall and dwarf. Okay, here height is the character. It has two contrasting forms, that is tall and dwarf. And next, shape of the seed. Here the shape of the seed is a character, and it shows two contrasting forms. That is, one is round and another one is wrinkled. Round and wrinkled seeds. The shape of the seed has two characters. And next, color of the flower. Okay, here color of the flowers is a single character, and it has two contrasting forms. That is, one is blue and another one is white. Okay, here in these contrasting forms, one is dominant character and remaining one is recessive character. Here related to the height of the plant body, tall is the dominant character and dwarf is the recessive character. And related to the shape of the seed, round is the dominant character and wrinkled is the recessive character. And next, color of the flower, blue is the dominant character and white is the recessive character. Okay, as you all know that the dominant character is always represented by the capital letters. And these capital letters, they are called as factors. Okay, here this tall character is represented by capital P and capital T, two letters. And these two letters are called as factors by the Mendel. These are called the factors. And for the dwarf, opposite form, the small letters, small t, the small t. Each character, each contrasting form is represented by two factors. Factors means these letters. A single character is represented by two factors. Okay, here also round, capital R, two factors, and wrinkled is small r, small. For color of the flower, capital B and capital B. And for white is a recessive character, so it is represented by small b and the small. This is regarding the what is monohybrid cross and who is the father of the heredity as well as the genetics. On which plants he conducted experiments and some contrasting characters. Characters and their contrasting form and how they are represented. The dominant character as well as the recessive character. Okay, this is regarding the monohybrid cross. Let's take an example, that is height of the plant body, that is tall as well as the dwarf. Okay, here monohybrid cross. This is definition. Okay, let's discuss this monohybrid cross by taking an example. That is tall tea plants. Tall tea plant is crossed with dwarf tea plant. So what happens when a cross is made between tall tea plant with the dwarf tea plant? Here tall is the dominant character and dwarf is the recessive character. They both are paired, tall tea plant as well as the dwarf tea plant. That first one is parents. Parents, or in other words, it is called phenotype. Phenotype is external morphology. That is tall tea plant is crossed with dwarf tea plant. It is the phenotype and parents. And next, related to the genotype. What it means genotype? The genetic constitution of an individual. Here tall, the character, and it is controlled by dominant genes. The dominant factors, capital T, the capital T. And next, related to the dwarf is small t, small t. Next, this is the genetic constitution of an organism. Next, gametes. Gametes. Here, homozygous condition, both are same. So, take gametes. For the gametes, you should circle the letters. And here also, small t, small t. Okay, when a cross is made between these gametes, the tall tea plant as well as the dwarf tea plant, we get it is capital T, the small t, and next capital T, the small t, next capital T, small t, capital T, small t. Okay, these are the progenies occurs in the F1 generation. This is F1 generation. The filial one or filial generation. Then what is the characteristic of these progenies? Okay, here capital T and a small t, and its character is tall. Here also tall. Okay, all the progenies which are occur in the F1 generation are tall in nature. But here one parent is homozygous, tall, and here also it is homozygous. But here the individuals which are occur in the F1 generation shows the intermediate character. Okay, they are not similar to the both the parents. The homozygous condition is there, but here one capital T, one small t is there. So all are heterozygous tall. Heterozygous tall. Okay, this occurs in the F1 generation. Next, when the cross made between the individuals which are occur in the progenies is self-pollination. When self-pollination occurs between F1 generation, this one. Okay, here also, let's take a phenotype. Is heterozygous tall and heterozygous tall. Heterozygous tall into heterozygous tall. And genotype, heterozygous tall is genotype is capital T and small t. Here also capital T is small. Next, after that gametes, capital T, small t. Okay, for the gametes we should circle the capital as well as the small letter. individual in the F2 generation. Okay, for this should make cross between these things is capital T, and next capital T, small t, and next here cross is made between small t as well as the capital T. So you should mention the dominant character first, dominant factor first. So the capital T, small t. Majority of you make the same mistake. That is, first you write the small t and then capital T. So that is wrong. First you should mention the capital T, and next small t, small t. Okay, this is the F2 generation. Okay, F2 generation. Here capital T and the capital T, tall, and here capital T and small t, it is also tall. Capital T and small t, tall, and small t is dwarf. Okay, these are the progenies which are occur in the F2 generation. This is F2 generation. Okay, let's take the ratios. The ratios of the F2 generation. Here, 3 are tall and 1 is dwarf. Okay, 100%, 100 plants. Okay, let's say assume 100 plants are there. In that, 75% are tall plants. Only 25% are small plants. That is dwarf plants. Okay, that is tall character and dwarf character, and its ratio is phenotypic ratio is 3:1. 3 tall and 1 dwarf. Like genotypic ratio. Phenotypic ratio, that is 3:1. Then genotypic ratio, here 1 is homozygous tall, 1 is homozygous tall, and 2 are heterozygous tall, 2 heterozygous tall, and 1 is homozygous dwarf. Homozygous or heterozygous, that is genotypic ratio. How much tall and how much dwarf is phenotypic ratio. That is 3:1 and 1:2:1 is the ratio of the monohybrid class. So what is the phenotypic ratio of monohybrid class? That is 3:1. What is genotypic ratio is 1:2:1. Okay, in phenotypic ratio, just you take the external character, that is how much tall and how much dwarf, 3:1. And here in genotypic ratio, you take homozygous and heterozygous condition. Okay, this is regarding the monohybrid class. Okay, tall pea plant and a cross made between dwarf pea plant. You take the phenotype, genotype, and gametes. Then you get F1 generation. But in F1 generation, parent characters, homozygous condition, they are failed to express. Okay, you get the intermediate character, that is heterozygous condition you get in F1 generation. But when a cross is made between these plants, within these plants, self-pollination is made within these plants, you get a genotype like this, capital T and small t. Next you get the gametes, and then you get F2 progenies. In the F2 progenies, you get both the character, both the parental character, that is capital T, as well as small t and small t. Both tall and dwarf you get. In addition to that, you get intermediate character. Okay, here this parental character, that is capital T and capital T, you get in F2 generation. Both the parental characters, they are failed to express in F1 generation, but they express in F2 generation. Okay, this is regarding the monohybrid class related to the tall pea plant and dwarf pea plant. Okay, let's discuss one more example related to the monohybrid class, that is shape of seed. Shape of seeds. Okay, pea seeds, they have two contrasting characteristics. Contrasting form, that is, one is round seeds and another one is wrinkled seeds. Okay, these are the parents of phenotype. Phenotype is round seed are dominant over wrinkled seeds. Okay, round is the dominant character and wrinkled is the recessive character. And next is genotype. Round is the dominant character, so it is represented by capital R and capital R. And wrinkled is recessive character and is represented by small r, small r. And next, gametes. Capital R, small r, small r. Then what are the progenies in first filial generation, F1 generation? F1 generation, you get all the seeds which are occurring in F1 generation, they are heterozygous round. Heterozygous round. Heterozygous round. Okay, here they won't have both the parental character, that is homozygous round, homozygous, that is R and R, capital R and capital R. Here homozygous condition, but here it has heterozygous condition. One is capital R and one is small r. It is heterozygous round. The round is the dominant character, so it is expressed in the F1 generation. When cell pollination takes place, between the F1 generation. Okay, here this is the F1 generation. Parents of phenotype. So this is the phenotype, that is heterozygous round is crossed with the heterozygous round. And next, genotype. Heterozygous round is capital R and small r. Capital R is small. Gametes is capital R, small r, capital R and the small. Then what about the F2 generation? The F2 generation, we have like individuals like that. There is capital R and the capital R. Cross, and the cross is made between R and R, and then R and small r, capital R and small r, then capital R and small r, and small r and small r. Okay, these are the progenies which occurs during the cross made between the F1 generation. The F2 generation, we get the progenies like this. It is homozygous round. Okay, it is also round. It's also round because dominant character is there, and here both the recessive characters, so it is wrinkled. Okay, here next, phenotypic ratio. Phenotypic ratio is 3 round, 1 wrinkled. 3:1. 3 round and 1 wrinkled. And next, genotypic ratio. Genotypic ratio. Here 1 is homozygous round and 2 are heterozygous round and 1 is homozygous wrinkled. So 1:2:1. This is the phenotypic ratio of the monohybrid class. Okay, whatever the examples you take, you get same ratio, phenotypic as well as the genotypic ratio. And this is regarding the example, that is round seed when a cross made between the wrinkled seed. Okay, we can take the another example works like color of the flowers. Okay, then only you get the same ratio, the same method. Okay, that is first phenotype, genotype, gametes, F1 generation. Then a cross is made between the F1 generation. The self-pollination is takes place between the F1 generation. We get again phenotype, genotype, gametes, and then you get F2 generation. These are the progeries of the F2 generation. Then phenotypic ratio and genotypic ratio. Okay, this is regarding the monohybrid class. In the next class, we are going to discuss about dihybrid class. A similar method. Okay, we will discuss in the next class. Okay, this is regarding the monohybrid class. Thank you.